Singularity.
My name is Nicola, aka Socrates, and you're watching Singularity One-on-One. Singularity One-on-One is a podcast feature of Singularity weblog, and if you guys enjoy the show, please feel free to express your support in one of two ways. Number one, you can go to iTunes and write a brief review for the show, and this would help us spread the word for it and let more and more people enjoy the show. And number two is, of course, by going to our donations page and submitting any funds that you can spare. My guest on today's episode is Dr. Anders Sandberg. Hi, Anders.
Hello.
Dr. Sandberg is a well-known transhumanist, futurist, and computational neuroscientist who is currently a research fellow at the Future of Humanity Institute in Oxford University. So let me begin our interview by asking you first, did I miss anything in the introduction, and how would you introduce yourself and what you do?
I'm an academic jack of all trades. I'm interested in almost everything, which of course drives my professors and bosses crazy because I'm never working on what I ought to be working on. But it also means that I feel quite at home in the philosophy department because it's at least equidistant from most academic topics. So over here in Oxford, I've been working on the ethics of cognitive enhancement, but also other aspects of neuroethics, but also issues of how we think about risk and cognitive bias, questions about brain emulations, questions about how we can talk about advanced future technologies and the far future of civilizations.
Those are all fascinating topics, and of course this is the reason why we got Dr. Anders Sandberg to be a guest on the show today. But let us roll the tape a little bit further back in time and begin probably in your childhood by asking you, how and why did you get to be interested in issues such as computational neuroscience, for example?
Well, I grew up in Sweden in the 70s, which was about as boring as you can imagine. I was living there in a big suburb of big high-rise buildings, very square. So of course I wanted to dream away, and I went to the local library and read every science fiction novel they had. And over time I wanted to make that science fiction real. So I started to understand, okay, I need to go to the science section. So I went there and started reading science, and I never stopped. Well, I'm still reading science fiction too, but the science turned out to be quite fascinating. So gradually I became a nerdy young man who was sitting at the library and making copies of interesting chemical formulas or equations. And then I found an interesting book, The Anthropic Cosmological Principle by Barrow and Tipler. And this book, well, I didn't understand that philosophy section, I didn't care for that, but it was a lot of interesting formulas. And it ended with a chapter where Tipler was kind of proposing his omega point theory, that in the really long run, advanced civilizations could literally take over the entire universe, could gain control of all the matter and energy, reorganize it in such a way that it could be used for computation. And as this far future universe collapsed onto itself, it got an infinite amount of energy that was used for infinite computation that led to a state that would essentially know everything. And of course, to a young nerd, that seemed like, whoa, the happy ending of the universe. So that got me started in thinking about the really far future, not just planning for the next decade or the next century, but actually going much further away. And then, of course, that in turn led to questions, okay, if we need to go into other galaxies, we need to develop spaceships. Okay, how can we do that? Oh, we might need to change society. We need other technologies. So it led kind of recursively backwards to questions about what should I be focusing on. In the years since, of course, I realized that, yeah, Tipler's omega point theory has some serious problems, among others that it requires a closed universe, and the universe actually seems to be open and going to be expanding forever. So we need to do something about that, or actually accept that maybe we can't get infinite computation, but just a lot of it. But still, it got me started on thinking big.
Yeah, those are some very interesting topics, and we're going to come back to them. But before that, I want to bring in a couple of two other issues that are relevant to your work, and I know that you're involved in, and those are the issues of transhumanism and ethics. At what point did you realize that you have to start looking at your work from an ethical point of view, or the impact of your computational work with respect to ethics, and how did you connect the two fields together?
Well, when I got interested in science and started to develop my scientific interest, I also became interested in transhumanism. In 1991, when I first got onto the internet, one of the first things I did was to join the Extropian mailing list, where I met fellow people interested in enhancing humans and going into space, and all that interesting science fiction-like technology that I cared about. To my dismay, a lot of their discussion was also about the ethics of doing that, which I felt, wait a minute, I don't care about that. I want the space, I want the rocket, I want the uploads. I couldn't really at first see the point of it, except that maybe it's fun to have that kind of discussion. But gradually I came to realize, wait a minute, if these really powerful technologies actually were to become real, rather than just entertaining discussion, they would impact lives quite strongly. This was something I intellectually understood early on, but it took quite a while before it really started to sink in. So throughout the 90s, I was kind of increasingly realizing that, yeah, maybe philosophy and ethics matter, but they're so hard to do. It's so much easier to calculate issues of spacecraft or what we need to simulate brains than to figure out the social impact. Especially since those social scientists, they were talking completely different language. I had no clue actually how to interpret their text. But gradually, as I started to read more and more psychology and the other aspects of the softer sciences, I became more and more aware that, ethics really matters. Quite a lot of my friends complain about ethics committees. And then I read Robert Heath's paper from, I think, 1974 about curing homosexuals with brain implants in the hippocampus. And that is able to convince practically everybody that, yeah, maybe the ethics committees are a good idea. The stuff people got away with in those days, yeah, quite horrifying.
Yes.
But the real point where I started thinking about the ethics was when I started debating the impact of cognitive enhancement in society. If this is such a good idea, why is it good? How do we even measure good? That's an ethics question. In order to convince people, it's not just enough to show that you're right, but you also need to convince people that this is a good idea in a moral sense. And also to something showing the pathos that you actually care about the idea. So that was the way I ended up actually involved in a project called Enhance, an EU project looking at the ethics of enhancing technologies, where I actually got to meet real philosophers and real ethicists, and I started to understand how tricky a job it is to actually do proper philosophy.
Absolutely. And so it's very interesting how your path started with sort of interest in science fiction, which pushed you into science and which eventually led you to ethics. So how did you do that sort of a transformation or getting engaged into the field of ethics? Where did you start to sort of educate yourself and find texts or materials which can sort of shed light on the work that you do as a scientist?
Well, don't tell the Oxford Philosophy Department about this, but I have absolutely no academic background in philosophy. I have studied a lot of topics, but formally speaking, I never studied philosophy. I picked it up by reading, indeed, books and papers and talking to philosophers. And that's also given me an appreciation that, yeah, it's very tough. I don't consider myself very good at philosophy. So that's why I'm quite often working in the form of translating science so philosophers can understand it, then co-authoring papers with real philosophers to get the philosophy right. I make sure they get the science right. And then I try to explain it back to the scientists and the public. But a lot of it actually comes back to, again, to the anthropic cosmological principle. That book is interesting because the first third is all about the philosophy of anthropic principles. The fact that our existence puts the constraints of the universe, which is a both profound and trivial fact. The fact that we exist here and can live as humans actually means that there has to be certain laws of physics that are compatible with our existence, which is kind of a trivial observation, but it also has profound implications. That kind of philosophy got me started because I was kind of very fond of the other parts of the book where were equations, physics, and the aspects of science and physics. But gradually I started reading other papers, and I was very much helped actually by the online transhumanist community Because these questions came up again and again, and people were pointing out interesting papers like Chalmers' Dancing Qualia paper, where he was debating whether an uploaded mind could actually have experiences or not.
Yeah.
So I think the internet was my philosophy library.
What other text other than David Chalmers would you recommend for people who are interested to sort of enrich their ethical point of view on human enhancement technologies?
Well, I must say that Nick Bostrom has done some very nice work, and we have been kind of helping him a little bit, although he's the brightest guy around here. Of course, we have various books and papers out on it. But in general, the debate about cognitive enhancement, that's a small area of ethics of enhancement. You also get into the interesting issues of the social impact. So we have Ronald Bailey from the kind of libertarian standpoint looking at it. You have Gregory Stock looking at it from a scientist standpoint. And then you, of course, got James Hughes looking at it from kind of American social democratic standpoint. So generally, the more you read, the better. Just looking at one big, good book is not going to help you.
Yeah. Just as a little side note, I've been trying to get Nick Bostrom for an interview for probably the last couple of years. So far unsuccessfully, but I'm still hopeful. However,
chaining himself to his desk, working on his big book, actually. So hopefully, once that book is finished, he might come out.
yeah, I hope so. His assistant told me that he's booked like, I don't know, a year ahead of time or something like that. So it's very tough. But I've had the pleasure of having both David Chalmers and Max Moore, Natasha Whittemore, Dr. James Martin, and a number of other people who you are familiar with probably on the show. But let me dive into the topic here. Why should humans enhance themselves? What is wrong with us the way we are, the way we have come to be after millions of years of evolution?
Well, the question is our current state optimal at some kind of peak that any change would make us worse off? Or are we somewhere in a slope? So there are directions where we would, if we change, we would become better by some standard. And it seems very likely that, no, we're optimal in some senses. But evolution doesn't care about our human values. Evolution cares, insofar you can say that the process cares, only about us having a lot of grandchildren. And that doesn't really carry very far. We care about other things. We care about our own lives. We care about what we enjoy. We care about not just that our grandchildren are having a good time, but about music, art, philosophy, games, sport, all sorts of weird things that are completely different from what evolution optimizes for. So if we want to do these things that give our life meaning, we might actually want to do something very different from what evolution has done. And of course, sometimes evolution can't even do it. There are limitations of evolutionary processes. Some things are too hard to evolve, or there's no way in the fitness landscape to get to it, or biology can't even do it. You can imagine, for example, that it would be useful to have bones that were much stronger and lighter. And we could probably have that if we had some kind of diamond laminate bones. But you can't do that using enzymes, because proteins can't really push carbon bonds strongly enough. And finally, there is this difference between our current situation and the one we evolved in. We evolved to live on the African savanna in small family groupings, which means that our intuitions, our brain systems are shaped by that, which doesn't work that well when we're living in big cities surrounded by a lot of strange people that are very different from us. We need to concentrate on abstract information much more strongly. And the big threat to our survival is no longer predators, but actually eating too much tasty food. We have evolved an interest in eating fatty food with lots of carbohydrates and a lot of salt. That was very healthy on the savannah because it was so scarce. So if you found it, you need to get it. Unfortunately, today we have succeeded in getting as much as we possibly could want, and the result is, of course, we are overeating. We definitely should do something about that. You can say, well, we can do that with willpower. Some people refrain from eating chocolate by just realizing that it would be irrational to eat too much. And that's sometimes true. But in practice, of course, we have a lot of evolutionary drivers that don't work that well. And we still want the pleasure and the cultural aspects of the chocolate. It's just that we don't want to get fat from it. We want our ability to focus on abstract information. But if our brains are too scattered, well, maybe we need some kind of Ritalin or some other cognitive enhancers that help us focus. We can change ourselves and we can change our environment. And sometimes it's much smarter to change the environment. But it's quite often hard to do that in a proper way.
So you've mentioned here that some of those issues give, to use your phrase, is give our life meaning. And those are the very deepest issues that ethics has a lot to say about. But I want to ask you, as someone who was trained in sort of traditional Greek and Roman philosophy, don't you think that Plato and Aristotle and the Roman philosophers have a lot to say about that? In other words, it is not only the modern philosophers who can contribute to the ethical point of view of those human enhancement technologies, but we can benefit a lot from going a lot further back in time to the ancients.
Yeah, I think that's very true. So looking back at Aristotle, for example, he's interesting because he has a psychological model of what ethics was. In his virtue philosophy, you're supposed to act in a virtuous manner. In order to become courageous, you need to do courageous acts. In order to be a magnanimous person, well, you should give away the right amount and do that repeatedly until it's a habit. So concept of becoming an excellent person was very much based on learning habits and changing yourself in the right direction. Much of later philosophy had been much more abstract and kind of following more in the Plato's view that, oh, we need to figure out what's right and then we should be doing it. The problem with that approach is, of course, that it leaves out the fact that we're biological humans that have biological brains, and our moral cognition is very psychological. We started to figure out some aspects of that using modern neuroscience. And the interesting problem is that we generally know what's right, but quite often we don't do it. From the perspective of Aristotle, that's not a terrible problem. Yes, you don't have enough of a habit. You need to work hard on your habit to become a virtuous person, aim at excellence. This is profoundly unsettling if you happen to be a Kant, for example, where we're supposed to be rational beings who figure out what we ought to be doing. And once we realize that we ought to be doing something, then of course we will do it, which is not how real humans work. This is, of course, a little bit of a caricature of Kant. It's a fun caricatures of him, and similar for utilitarianism. But generally, assuming that psychology has little role is a problem for thinking about ethics, especially when we get to enhanced ethics, because a lot of that is, of course, tied to the question, well, what makes a human flourish? What produces an excellent life? So one of the standard arguments against enhancement is that, well, if I could enhance myself, I wouldn't be so virtuous. I wouldn't be doing good things. I would just have help of my enhancements. I think that's wrong. I think the enhancement is like a chair. I can stand on a chair, and that means that I can reach higher up. Of course, I can be lazy. If I want to reach a low book on a bookshelf, I can stand on a chair and very easily grab it. But I can also, of course, try to grab books further up. So there is still a need here for virtue and training yourself and aiming at something bigger, not just going for the easy solutions. But I think enhancement might allow us to go much further out in what than would have previously been possible. It's a bit like education. In the past, it was very hard to get information necessary, which meant that education was mostly about having a good memory. Gradually, it became easier to get the information. And now it was less about having a good memory as organizing, understanding. And now we can get this amazingly large amount of information with the internet. And suddenly we need a new virtue to deal with information overload instead. It might not be about knowing where to give the information, but knowing what information to leave out. Similarly, I think enhancement is going to lead to the development of need for new kinds of virtue, many of which ones we have no clue about at present.
So what, in your opinion, are the most interesting enhancement technologies that you have come across, or the most promising ones that we should be focusing most of our efforts towards?
So it's an interesting difference between what is kind of scientifically really interesting and useful and what might actually change the whole world. So, for example, I've done a lot of work on the ethics of cognitive enhancer drugs. And they're nice. They already exist. People are already using them. They pose various ethical dilemmas, so they keep us in the ethics department nice salaried. But unfortunately, they only at best give you 10 to 20% better performance on some tests in the lab. And we don't even know whether they work well outside the lab in real world. Nobody ever done a study of the test scores of students taking cognitive enhancers, whether they actually get improved. We don't know. It could be that they're really good. It could be that actually they don't help at all. That's to find out, but it's hard to get an ethics approval for investigating that. However, then you have other tools like transcranial direct current stimulation, which is interesting because it's so trivial. You just send a weak electric current across the brain. And by changing the polarity, you can get some part of the brain more easy to excite than, or less easy to excite. And this can enhance, not enormously, but it's a very simple tool, which is also interesting because it's slightly scary, because you can almost imagine people going to Radio Shack and getting the equipment. It's not going to be possible to regulate, and you probably want to know exactly what part of the brain you stimulate. However, these are producing relatively small enhancement. The enhancement that really change the world are the ones that string brains together. Because communications enhancement that allow collective cognition to become better, have a much, much bigger impact. So once upon a time, we were very isolated from each other. It was hard to communicate because we had small communities and we could only send letters to each other. Gradually, we got faster in communications. It becomes possible to interact more quickly. That means that the overheads of getting groups together has been reduced. You can get larger groups together, and you can also organize the groups more fluidly. We don't really know how to do this very well yet. We're just starting at figuring it out. But already interesting experiments in crowdsourcing we're seeing are ongoing. We're seeing interesting scientific demonstrations like the Galaxy Zoo, a project from here in Oxford where people catalog galaxies, where you have an online community that not only does pattern recognition, but also discover new scientific findings, simply because as a hobby, they're watching a lot of galaxies. We're having people solving protein folding problems as computer games and doing really well at it. Occasionally, we get these amazing things in alternate reality games where a team of people who are really interested in solving puzzles get together and show a group intelligence that is much more powerful than any of the members. The problem is, we don't know how to reliably get this for important problems. Just imagine if a government could come together like these alternate reality games and become much smarter than any of its members. That would be an amazing and perhaps terrifying thing. But we have no clue how to get that on order. We're starting to figure out that in some problems are very good for groups, other problems are bad for groups. So for example, if there's a problem where once you find a solution, everybody can agree, we found it, and you can deliver the solution. Groups tend to do very well on those. However, problems where it's unclear whether you actually have solved the problem in the first place, the so-called vexed problem, where it's unclear whether a solution is a good one or a bad one, or even how to measure it, groups actually do worse in tests than just taking the members and individually having them write up solutions and then trying to judge whatever they come up with. So we're learning, and technology is helping here. Of course, most of that technology is not going to be the amazing brain implants or other things. It's going to be things like the smartphones, which are amazingly powerful tools and already changing our cognition in ways we're not really aware of yet. So the fact that Wikipedia works, that's kind of evidence that there are probably forms of cognition enhancement that are tremendously powerful out there, and we just started.
Mm-hmm. So let me ask you here. I interviewed Professor Kevin Warwick from Reading University a couple of times, and he sort of threw a friendly challenge towards Ray Kurzweil by saying, why hasn't Ray experimented with implants yet? Let me point that question towards you. You work in the field. You have been working for some time now. Why, or are you planning to ever have a sort of a direct first-person experience with some of that technology that you're working on.
I have tried cognition-enhancing drugs. I kind of outed myself in times about that, so it's not a secret. And then I actually wrote a little paper about the ethics of ethicists testing the substance that they're writing about the ethics of. There are some very interesting questions there, actually. Is this biasing me in a bad way and so? But when it comes to implants, well, I've been seriously thinking about getting one of those magnets implanted to get magnetic vision. The main reason I haven't done anything on that is that I'm still marginally a neuroscientist, and I want to be able to get close to magnetic resonance imaging machines, which I wouldn't be able to have if I had any magnetic parts of my body. Similarly, I've been thinking, well, body modification, maybe I should get myself some tattoos. And I'm completely happy with the idea, except that I realized I would be changing what I want once every day. I simply couldn't settle on a single design. So in that case, let's wait until we get technology for tattoo I can reprogram every day instead. Which, of course, many tattooed people would say, that's kind of missing the point. One of the interesting aspects, of course, of many body modifications is that they're permanent. They're actually a change of view rather than a little bit of clothing that you decide on in the morning. Today I want to have this kind of tattoo. So there is something interesting about it. So in my case, it's not so much squeamishness as a kind of practicality. However, if I knew that I could somehow turn off the magnetic vision whenever I got close to a magnetic camera, well, in that case, I would probably get one in a jiffy. I really want to see if there are beautiful magnetic fields out there.
I personally have to share with you that I have that sort of early adopter factor in everything that I do with respect to software. Or even hardware. I build my own computers and so on. But when it comes to my own body, I am very concerned about early adopters' risks, because if it's unproven technology, it's one thing to put it on my PC or take the hardware element and stick it inside of my box here. It's another thing to make it a part of my body, because if things go wrong, then the implications are much bigger, obviously. So I have to say that I'm very fearful when it comes to personal body modification.
And I think that's entirely appropriate. We should be very careful about what we do. But it also means that we should really be recognizing the pioneers, the people who dare doing experiments with themselves. Although sometimes we do it for reasons that might not be well advised, we're still learning from it. And we should recognize that they're, in a sense, heroes doing that. My biggest annoyance with Kevin Warwick's work was simply that he didn't write enough papers about all the little details. I want more information. Similarly, a lot of people in the body modification community, most of them are not doing it for any scientific reason, but I would love if they documented more what they were doing, because it would actually be very useful. The questions about how do you experience things from magnetic implants, for example, are actually philosophically quite profound and interesting. Very interesting questions about self-image when you actually modify how you look. So we should try to get as much information out as possible. Similarly for life recording, which is not exactly modifying your body, but you're still putting a large part of your life now in a potentially shareable form, which is almost as scary, I think, as doing something to your body.
So let me connect all of this with your personal work. You already shared that in a way you act as a bridge between the philosophers and the scientists. You kind of help the scientists to write papers with more philosophical awareness with respect to ethical issues, and you help the philosophers get the science right, as you put it. So what is there a more specific, more explicit purpose or goal or a benchmark of your work? Say, in 20 years, what would you like to have accomplished?
I would have what I really like to accomplish is to get people interested in the most important questions. So this is one of the things I have learned from my colleagues here in Oxford. Our priorities are often in the wrong order. And the most important things are quite often an order of magnitude more important than the second most important one. So when we rearrange the ordering of our priorities, that can have an enormous effect. And quite often, of course, both in philosophy and science and in everyday life, we don't care enough about getting that priorities right, which means that we spend a lot of effort on unimportant problems.
Yeah.
It might be very hard, of course, to figure out what's most important. Quite often it involves profound questions about our ignorance. But even trying to get it a little bit more correct can have an enormous impact. So I hope to get people interested in some issues that I think will have an enormous impact in the future. For example, various forms of cognitive enhancement. I think that could actually change our society for the better in a very large scale. Similarly, the concerns about existential risk we have here at the Future Humanity Institute, we kind of realized, or at least we convinced ourselves, that these are much more important than most people think, and they're understudied, and people are not taking them as serious as we should. The fact that there are 3 times as many scientific papers about dung beetle reproduction than human extinction is a very sad fact. And I like dung beetles. I collect beetles. I really think there should be a lot of paper about it. It's just that we as a species are probably rather dumb if we don't focus more on keeping ourselves alive.
Mm-hmm. And where does the sort of Future of Humanity Institute in Oxford fit within these goals in the overall picture? Perhaps some of our viewers and listeners are not familiar with your mission there.
So our work is about the big picture, long-range thinking. We're trying to really think about, well, what would change the future of humanity, and can we do something useful about it? So one area we're interested in is human enhancement. How can we change in the future thanks to our technology? And what can we do about that to make sure that the outcomes are good? Another thing is human extinction and global catastrophic risk. How can things end very badly? And what can we do about that? Then we have a question about emerging technologies. What technologies are appearing that could change what it means to be human? For example, if we had some infinite amount of energy, that would be very nice, but it wouldn't actually change what it means to be a living human. However, if we got a way of doing brain emulations, suddenly you could get a form of digital immortality, you could have backup copies, you could have multiple persons. That would really change what it means to be human. And finally, and this is kind of why we're in the philosophy department, we're dealing with applied rationality. We're trying to think about how can you think about these questions where we don't have all the data. And it's not just that we lack data about the future. In many of the cases, we have profound ignorance. So how do we do decision making and reason about the future when we know we don't know all we should deal with? Normally, the engineering approach is to say, oh, if you have no information, you can't do anything. But we actually need to act in many cases. The political approach would be to say, oh yes, but I have an ideology that tells you all the answers, which is of course problematic because that ideology, we don't know whether that is correct or not. Philosophers are actually surprisingly good at doing good reasoning even when we don't know very much about the domain. I'm usually saying that in philosophy, as soon as we figure out how to think carefully about something, it tends to move out and become its own department. And it could be natural science, it could be psychology, history, economics. All these areas have been philosophy. But as they got their act together, they moved out, became their own department, and got a lot more money. And everybody are still looking at the philosophy department wondering, whatever have they ever achieved?
Yeah, I agree that unfortunately there is that kind of attitude towards philosophy. But we're all working to change it in our own way, right?
Oh, yeah. And the nice thing about philosophers is that we're also unafraid of getting involved in areas, both outside of philosophy, but also areas where we don't know very much. That's actually the kind of juicy, interesting domains for them. Areas where we know a lot, well, they're not that interesting to investigate because a lot of people are already doing it. And also, if you want to change the course of history and so on, well, should you focus on the areas where a lot of people are working, where almost nobody is doing it? And the answer is, of course, go for those areas that might be important, but few people are investigating. You get to be one among the few, and if you even nudge it a slight bit, if it's really important, you might actually affect the future of humanity.
Mm-hmm. So, speaking of those areas that are perhaps among the most important, Which one would you say, in your opinion, are the sort of most controversial from ethical point of view?
It's interesting to notice that cognitive enhancement doesn't make people that excited. However, when you get over to aspects of emotional enhancement, people get much more excited. And I've written a few papers about the chemical enhancement of love and marriage, and that really gets people upset because now it gets close and personal.
Yeah.
We care much more about kindness and love than we care about memory. So as soon as it gets close to our kind of core human values, people get very uncomfortable with any form of modification. Similarly, life extension is something that tends to upset people. I find it rather bizarre that people get almost angry when you bring it up, but very, very natural explanation. We have to come to terms with our mortality one way or another. So most of us construct some elaborate structure, so that makes us able to get through life. The problem is, of course, when somebody comes up and says, maybe you don't need to die, maybe we can solve this with a pill or some treatment or gene therapy. And then that threatens that big structure you set up in order to retain your calm and live a good life. Of course, people are going to defend themselves against that idea because you're actually threatening to some extent their mindset. Mm-hmm. I think this is irrational and it's holding back important research and actually hurting us in a lot of ways, but it's also very, very human. So the weird problem is that we get upset about the things that maybe we should be investigating the most. And then, of course, there is the opposite problem. There is things that people don't care at all about when they ought to be caring about. Mm-hmm. It's quite common for people to say, you worry about artificial intelligence. But that's a silly topic. Nobody needs to worry until we build it. Mm-hmm. Which, according to our analysis, is, well, once you built it and it becomes good enough, it could be terribly dangerous. Yeah. The weird thing here is topics move between being silly and non-silly, not because of accumulation of knowledge, but for social reasons. For example, climate change, I moved from a kind of silly theory over to something that is deadly serious, and if you don't believe in it, you're a bad climate denialist. Mm-hmm. You probably get run out of a city with tar and feather, at least over here in Europe. But what was that shift? Well, that was kind of gradual growth, a bit of understanding, but also about convincing intellectuals and people that this was an important question, that we need to change our culture and society. However, other dangerous risks, like risk from synthetic biology, are kind of just not taken as seriously. So the problem is we have a kind of risk budget. And where people put their efforts has relatively little to do with how big the risk actually is. For example, I'm really fond of defending Earth against asteroids and meteors, and it's one of the big threats that we actually have the best handle of ever. Mm-hmm. And the people in the community would be a bit shocked by if I said that, because they know how hard it is to get funding. They're a rather small community. But it's actually a topic where we know a lot of things. We have data, we have plans, we have scientists to understand what we could do. We even have some public understanding. In most of the big risks against humanity, like risks from nanotechnology, you don't have that. You have misunderstandings among the public or policymakers. People worry about the wrong things or even dismiss the whole question as silly. Mm-hmm. So the problem is our management of risks is kind of irrational. And this is not just true for big global catastrophes. It's also true for financial risks that we've been seeing in financial markets over the past few years. So in general, humans are bad at thinking rational about risk. If we could change that, I think we would win a lot.
Yeah, I agree entirely. But grabbing your thought about that, perhaps the things that we fear the most are the things that we should focus a lot on. I want to share perhaps just briefly with you that a marine biologist that I talked to some time ago about life extension technology made this shocking statement to me that he basically said that people who work on life extension technologies should be shot because they are wasting resources and our planet has much more urgent problems than death of natural causes, as he put it. And of course, he's coming from the point of view of a marine biologist with the destruction of the coral reefs and all those things that are caused by humans, in his opinion. And therefore, if we are to live longer, the damage would be only bigger and so on. So there's that kind of attitude which to me was shocking from somebody who is very intellectual and very well educated in other fields.
There is also something interesting about it. I wonder what they would say, and that's also why we should shoot all artists. Of course, we're wasting a lot of effort on art. And this is the general problem. When you actually start thinking about priorities, it seems like we're spending a lot of resources on things that might not be the most important. Yet some of them are probably important in order to live a human life, and some of them are important because humans need, in order to live a good life, to actually have a freedom to pursue them. Then there is, of course, the kind of real issue. Well, we would probably need to figure out how to handle resources if we live for a long time. I think it's a much smaller problem than that marine biologists think, partially because, well, it's actually birth rates that matter, and as people live longer, they actually do seem to become much more green, because they know that they need to put up with the consequences of the consumption later in life. So I'm not too worried about that. But you do get to this interesting question. For example, in the case of artificial intelligence, we have convinced ourselves at FHI that, random artificial intelligence could potentially be extremely dangerous. And we need to rein in a little bit what it would do. Mm-hmm. This is not good news for the artificial intelligence community. They generally don't like hearing that. Yeah. All scientists like to hear that they're doing good research that's going to help humanity. Hearing somebody tell you that, oh, that's dangerous, is not a welcome thing, even though sometimes it is true. Even when the people actually are thinking about safety and security, like in biotechnology, typically people are willing to say that, our technology is so powerful that it needs to be having some safeguards. But when you propose safeguards, people become very defensive. But that's part of the game. That's what's happened in any other topic. Think about the financial sector. The finance people are very happy to say, we need to avoid further crashes. But they say, no, we don't even need that particular regulation. So the problem is, of course, finding the right priorities and agreeing on them. Partially that requires us to be able to understand more about the topics. So in many cases, we have a surprisingly large lack of information. For example, we don't really know the long-term effects of some of the cognitive enhancers given to kids. Despite being used for a long time, Ritalin, we still don't have that good long-term data about its health effects, which is bizarre. It's been using for 40 years by now. And we have big gaping holes in our knowledge. Now, if we could figure out better ways of filling them, I think we could also have smarter debates. And then we could also probably have a bit more shared ground rather than discussing who should be shot. Or as we were discussing at one workshop, maybe we should put a philosopher next to each AI researcher, just keep them busy and keep them away from actually doing any useful work.
Yeah, somebody would say that's the best way to never get anything done. But we've been talking about some issues related to ethics and the good life and so on. But another important point of view that claims to shed a lot of light on those issues is, of course, religion. So let me ask you this. First of all, are you religious?
No, I'm not.
Meaning agnostic, atheistic?
I kind of grew up as some kind of somewhere between atheist and agnostic. The problem with atheism is that if you want to be a proper Bayesian and assign probabilities, you can never assign a probability of 0 to anything, because then you end up with a lot of irrational behavior. But it doesn't seem to be a good model of the universe to assume any kind of traditional religious creator. And once you get into the non-religious possibilities of creators, things get really weird.
Yet issues such as cognitive enhancement or especially life extension technologies would certainly have, in my view, a very considerable impact on most major world religions.
To some extent, but I think we often underestimate how resilient religions are. If you look at the places where religion have really declined in importance, that's the areas where, like Scandinavia, where you have a nice welfare system. You don't need to worry too much about if things go badly for you. You have safeguards, which seems to suggest that religion is much more about social safety nets than explanations of how the world works. The old ideas that, oh, science will explain everything and then people will naturally become atheists have not turned out to be true. Rather, it turns out that people select the explanations that make them feel happy, which makes, of course, philosophers rather unhappy, because ideally we should be aiming for truth rather than something that feels good. But I think in general, religions are good at taking up new technologies. It's relatively rarely they simply cannot handle them. Instead, they will kind of find a way of explaining how to deal with it. So cognitive enhancement, I don't think that's going to threaten religion that much. Actually, there have been some interesting arguments in the past that this might even be a good thing. When coffee was introduced in the Arabian Peninsula back in the 12th century, there were some debates whether it should be banned. After all, it's a bit like alcohol. And a lot of Muslim scholars, of course, immediately brought out, no, it's the opposite of alcohol. Alcohol makes you dumb, this makes you smarter. So hence, since Allah is against alcohol, he should be in favor of coffee. And you can imagine the same kind of thinking, of course, in a lot of religions. Life extension, similarly, if you actually think about, for example, the miracles of Jesus in the Bible, all of them, except for cursing that poor fig tree, were all about kind of improving life and getting people to live longer or even come back to life. So I don't think it's going to be a tremendous problem in that regard. You really need something that completely turns the human condition upside down to get religions into trouble. So if, for example, brain emulations turn up, at that point you need to deal with, okay, can software be a member of a church? Can software get salvation? And if I make a copy of myself, or we're having separate souls and so on. But I have no doubt that clever religious people are going to find some nice way of integrating even that with their worldview.
Yeah, my concern is mainly with the sort of more orthodox streams of religion who have a very literal reading of their own books, and who might oppose many or most of those technologies, just like they opposed, for example, vaccinations or antibiotics and things like that in the early 20th century. But speaking of religion, one of the criticisms often leveled towards the technological singularity is that some have called it rupture of the nerds or religion for geeks. So let me ask you briefly, what's your take on the technological singularity?
I think it might happen. It might not happen. I would give it perhaps 25 to 30% chance of being something that occurs. But there are many different kinds of singularity. So it's not just one concept. There is the accelerating technology account that Kurzweil uses. But then there is also the issue of that it feeds back and it becomes extremely fast, which was originally mentioned by I.J. Good back in the 60s and was part of Vernor Vinge's concept. Then there is this horizon that we cannot predict anything behind it. And then the concept, well, actually, the important part is superintelligence. And then you have various other ideas, like it might be a phase transition to higher orders of organization, etc., etc. It's all very confused. Most people speak about it like it was a single thing, when they actually mean a subset of some of these concepts. I think it's pretty likely that we're going to see very rapid technological change. And if we do get any form of copyable human capital, whether that is machine intelligence or brain emulations, we're going to see at least an acceleration in economic growth, as per the papers by Robin Hanson, that is going to be like the Industrial Revolution, but crammed into a few years. That's enough to be very, very scary. It might not be the ultimate technological singularity or so, but it's still very worth thinking about, because that kind of rapid change might be very turbulent and very dangerous. But it might, of course, turn out that we're wrong about it. We should be open for these possibilities and try to plan for, well, all these futures. What plans would make sense if we had a singularity and if we didn't have a singularity? What kind of policies make sense if we don't know how the future exactly is going to look? Can we, for example, get better feedback into the policy making, so the evidence ongoing on the internet, for example, could help us adapt even if something happens very rapidly? The singularity should not stop us from thinking. I think quite often people use it as a kind of nice endpoint of thought. So that's where it becomes a rapture of nerds. You can add various religious or millennialist thinking to it, and you can say, oh, I don't need to plan for my pension because the singularity is going to occur before that. But first of all, how do you know? And second, maybe it's a smart idea to plan for a pension because you might need it after the singularity. Yes, you might be post-human, but you might still need the money.
So you said we had 25 to 30% of it happening in your estimate, but what are our chances of surviving it were it to happen?
That's a good question. I'm an optimist. I think they're pretty good, but the kind of office consensus around here when we were kind of trying to estimate it is that we think there is about a 12% chance that humanity goes extinct this century. We're dealing with some rather dangerous technology. Some of them fairly old. People tend to forget nuclear wars, but think about it. We had at least one Cuban Missile Crisis where, according to Kennedy, it was about 1/3 chance that the buttons might have been pressed.
Yeah.
And there have been several rather scary close calls. And that's just nuclear weapons. Then we have the emerging technologies like biotechnology. We have nanotechnology. We have artificial intelligence. And we also have threats we haven't thought about. Supervolcanoes, for example, were completely unknown until a few decades ago. And meteor impact, well, again, a century. So we're probably going to discover some threats we didn't know about. And we're probably going to invent new kinds of threatening technology. So I'm optimistic. I think we have pretty good chances. But it might be that even a singularity we survive might still make the world not entirely to our liking. So that's why we should aim at resilience. We should try to understand as much we can about the future so we can at least guide those parts we have control over. For example, we can't prevent so many technologies from happening, but we can change the order they happen in. So if we think, for example, that nanotechnology is dangerous and artificial technology is dangerous, but AI helps us control nanotechnology, then we should push for AI. And if we think brain emulation is better than AI in terms of being controllable, this is my personal view, then we should try to get that before AI.
Dr. Sandberg, we're coming to the last sort of 3 or 4 minutes of our interview here. So for those of our viewers and listeners who would like to find out more about you and your work, what's the best place to do so?
I think going to the Future of Humanity Institute website is a very good start. Also, some of my papers can be found on Nick Bostrom's webpage, which is itself a very good one. So I co-authored a number of papers with him. So I recommend going there.
And is there a single thing, a single message that you would like our viewers and listeners to take away from this interview with you today?
I think my main understanding, the one thing I learned from years at the university is that I'm pretty stupid. And so are you. And we are all amazingly stupid, but we can get better. By realizing that we can improve our thinking, we can actually figure out better ways. And as soon as we think a little bit better, we can make the world much better.
Wow. That's a fantastic way to end our conversation. Dr. Anders Sandberg, thank you very much for being with us today.
Thank you.